Okay, so there's a wee bit then of velocity time graphs. I'm actually going to do a different example before this one, but that's okay. We're looking at velocity time graphs, so they plot along the bottom as time and up the side as velocity. So as time goes along, it tells you the velocity at different stages. We'll chat a bit more about that as we go. Two main points to remember: the gradient or the steepness of the line is the same as acceleration, and the area under the graph is the displacement, the distance travelled generally. So let's take a wee look at a different example. This is example 1. I'm going to look at example A first of all. We can try and find some information in about there. I'd like to know what's happening between here and here, between here and here, and between here and here. So I'm going to call this the point A, and the point B, the point C, then the point D, and have a wee think then about what's going on. Alright, so first of all then, between A and B, it starts here at time is 0. That's of course going to be in seconds. And then it's a velocity time graph, so this is our velocity, so this is going to be meters per second. And it starts at 5 meters per second, and after 3 seconds, it's going at 10 meters per second, so it's getting quicker. And that's a constant acceleration. You could use UVAST to work out your constant acceleration, but we've just been told that the steepness of the line, or the gradient of the line, is the same as the acceleration. So we're going to do rise over run. Rise, how far does it go up? It goes from 5 to 10 there for that line. So that's going to be 5. And then as it go along, it goes along 3 because it's 3 seconds. So our gradient is in 1 2/3. So between A and B, there's acceleration of 1 2/3 ms to minus 2, or meters per second squared. What about between B and C? What's happening? So time is passing, 2 seconds passes between here and here, between 3 seconds and 5 seconds. I've made a mistake there, actually should have drawn that differently. We're going to change this to here. Oh, what a palaver, sorry about this. I can't count to 4, obviously. We'll take this journey here. I don't know if we'll be able to rub this out quick enough. Yeah, hopefully that's not great looking, but sure it will do. Takes us from here to here, so that gets us from there to there. So 2 seconds, but it hasn't changed speed. So that's just, or it hasn't changed velocity, so that's just a constant velocity. So that's constant velocity, and that's then for 2 seconds. And then between C and D, what's happening? At 5 seconds and 7 seconds, there's a big change. At 5 seconds, it's going at 10 meters per second. And then at 7 seconds it stopped, so it's decelerating. So we have a couple of things. We call it retardation or deceleration. It's the same thing, and of course the steepness of the line is the same as the gradient. So with retardation, the rise there is 10, the time is 2, or the run is going to be 2, and so that's going to be 5 meters per second squared deceleration or retardation, or if you want minus 5, sorry, we'll put in units there, so meters per second squared acceleration. So that's generally what's happening here. So this thing starting at 5, over the period of 3 seconds it speeds up again to 10, it goes at 10 for another 2 seconds, and then slows down then to 0. So that's what we have then from there. You can use UVAST to work this out, or to work this out. You could use, that's just constant velocity, so you could use distance, speed and time to work out that and things, so we can suss those out if we want. What we're going to do is find the distance travelled, the other piece of information. So we have 2 main pieces of information which we've used. Let's go back to them. Gradient is acceleration, area under graph is displacement, so we're going to be working out our displacement. So we're going to try and find the area of this. We're calling that S1, displacement 1, displacement 2 and displacement 3. S1, we could do it a couple of different ways. We could split that into a wee rectangle and a triangle. You could do it that way, or if you want then it's trapezium, so we could find that. So let's do area is a half A plus B upon H, and so its area is a half A, that's 5. That distance, remember it's a 2 parallel sides, so that's just 10, and my height H is 3. So that's 15 times by 3 is 45, divided by 2 then is 22 and a half. And so we have that. Our S2, straightforward enough, base times height, because it's area, so that's 2 times by 10. Which is going to be 20 meters traveled in that time. And of course, remember, it's going at 10 meters per second for 2 seconds. Of course, it's going 20 meters, or if you want, it's distance, speed, and time. Distance is speed times time. The speed is 10, the time is 2, so it's that as well. It's just showing they're all one and the same, really. And then S3, the area of that is a triangle. So what do we have? That's a base of 2 and a height of 10. So area is, so you can't see that, a half. BH, area is a half times 2 times 10. And that is going to be 10 meters. So therefore total distance travelled is going to be 22.5 plus 20 plus 10, 30. So 52.5 meters gets travelled then on this journey. So that's just some information and a bit of an introduction then to our velocity time graphs. It tells you what happens to the particle. It's getting quicker, it's getting quicker, it's getting quicker, going at the same speed for 2 seconds and then slowing down. Gradient tells you the acceleration or deceleration or retardation, and the area underneath the graph tells you your distance travelled or your displacement.